go. This is how to do every stoichiometry problem. And I wrote down the steps for us earlier, but we have that, like, what's the right thing? We have like step one, balance chemical equation. This guy right here is already balanced for us, so we don't have to worry about it. That's good. If it wasn't balanced, we'd have to do the work. Step number two. You guys remember what step number two is? This is the one that gave us a lot of problems.
Finding our knowns and unknowns?
Yeah. And I'm not sure why it gave us a lot of problems, but let's see here. I'm going to put known down and unknown. UNKNOWN. Did I spell those right? I'm going to pretend like I did. So what is the known quantity in this equation?
Would it be CO2O3?
So that's not a known quantity, that's a substance.
Oh, okay.
So how much of the substance is there?
3.38 moles.
It's 3.68.
6.8.
Yeah, but we got it. 3.68 moles of CO2O3. And my unknown is grams of COO. So step one, balance chemical equation. Step two, known and unknown. Now step three is setting up my problem. Now, if I know that I have moles, I will say, all right, I am starting at moles right here. I'm kind of making a green circle on it. Moles of the known substance. And I'm going to need to go from moles of one thing to moles of another. And then I need to get to grams. So I'm going to go from moles to mass. So when we're doing this equation, you will write out that we have, it's going to be some number of grams of COO is equal to, and then we'll have our long series of things going on from there. We start with the 3.68 mole of CO2O3 and then multiply, and we will make one line for that. So there's my line, poorly drawn. And that is going to be, that's this step right here. So that's where that comes from. And I'm going to erase that arrow so it's not too janky. Then I'm going to be multiplying by another line. And this is going to kind of trail over into other things there, I realize. And that is just going to be from this guy right here. Now, when I'm showing you guys, there's these things on my mole map. That is the secret to solving these guys, is the mole map. As you're going across from this, what does it say where my arrow just went?
Mole to mole.
What about on that line?
Use the coefficient chemical equations.
Yeah. So what numbers are going to go in?
4 COO.
So, I mean, like, we want to say these are the coefficients from our balanced chemical equation, that guy right there. Now I've got one is that 4 COO and the other is the 2 CO2O3. Like those are those guys. We see those numbers right there, right? We're all happy with that.
Yes.
Now, the question really becomes which one goes on top and which one goes on bottom of that first line, and then why? And I am keeping a list right now for extra credit. I've already gotten you on the list, Manny, but somebody else tell me which one goes on top, which one goes on bottom, and why.
I don't even know, mister. I couldn't even help.
All right. So what are we trying to do with all of these fractions?
Turn them into not fractions.
But like, why do we have the fractions? What's the point of doing this dimensional analysis stuff?
I don't know, mister. I really don't.
Do you remember what the other name of it is?
I don't.
Something about factored unit something. I don't really remember what it is.
Like greatest common factor or something?
Well, I mean, we do that for balancing, but to get these guys together, like why we have all of these things is, do you notice if I'm erasing these here, and then we know it's 4 and 2, we have up here a chemical and another chemical. Is one of those the same as what I have written down at the beginning of my equation?
The CO2O3.
Yeah, it's the same thing.
Would they cancel each other out?
That is entirely the point, is to get them to cancel. So when I write it in, which one do I want to cancel? It's always the thing that you already have. So whatever this is right here, this unit, I'm going to try to cancel that guy out. So how many moles of CO2O3 are in my balanced chemical equation?
There are 2 in the chemical equation. So would we always cancel off our known?
Well, yeah, because you already know that one.
All right, cool. That is something I'm definitely gonna note down.
So when we set these guys up, the tricks are we're trying to cancel out the stuff that we have. In this case, we started with moles of CO2O3. And now that I'm there, I can cancel it. You know, you can think about this as being all over one because that's the identity of something. And then when I get there, I'll just say, all right, we're going to cancel out that mole and we're going to cancel out this mole. Now on the second line on the mole map, and I'm going to redraw that guy in red as we're doing it, I'm going to do from moles of cobalt oxide, 2 grams of cobalt oxide. And what does it say on that line for me to do? Can you read that for me, Christian?
The 1 mole equals molar mass.
Yeah. Now, where do we find molar mass?
Is that the atomic number
It's,
or mass?
I mean, we go to the periodic table and it is on it's not the atomic number, but it's like the other number.
The atomic mass.
Yeah, the atomic mass number. So I'm just mousing over cobalt so that I can stick my side work down. And the grams per mole is that large one, 58.933. And this is kind of an easy one because that's one cobalt, and oxygen is the other guy. And oxygen is very small. Hang on. There we are. 15.999. Then I can go back to the question just that I can try to type in the answer and see if we've got it. So you want to use a calculator, or you can do it in a extra browser tab. You can say 58.933 plus 15.999 and it equals 74.932. That's all. I'll erase the other guys so they're not gumming up my work. I'll move that guy to a little bit easier to see spot there. So now I go back to my question itself. And I need to, I know that that is that many grams per mole. So I've got another, right, another fraction bar to deal with. With this other fraction bar, I have grams and moles. Which one is going to go on top or bottom of my equation and why?
I would assume that you put the grams per mole on bottom to cancel out.
Wait, grams per mole is two things. Grams is going one place, mole is going the other place.
I'll put the mole on top and the grams on bottom. Because wouldn't the grams have to cancel out the CO?
So it's going to be grams of cobalt oxide per mole cobalt oxide. And what you always do is look at what you have there. What do I have there? You see what I circled in green?
Mole of COO.
That thing has got to go on bottom to cancel out. So I need to put mole of COO on bottom, and the grams have to go on top. This will also, you remember what the known and unknown were. This should give me the unknown. That's grams of COO. That needs to be on the top when the problem is done. So when we set, oop, that was too many. When we set these guys up, we need to cancel, always put on bottom of the next fraction whatever was on top of the previous fraction. And in this case, it is, I'm writing it in a weird place so that we can see it, 74.932 grams per mole. Then my moles can cancel out. So those guys can go goodbye. And all of this is going to say the grams of COO, which is, if you look at the beginning, yeah, that's what I wanted it to equal. I wanted it to equal grams of COO. This last step, you just punch it all into a calculator. Oop, wrong thing, undo. So I can say, let's clear it. I've got 3.68 times 4, then times 74.932. Then I'm going to look at the bottom. I have a 2 on the bottom. There are a bunch of 1s, but I don't need to put them in. Divided by 2. And I've got, that is like a really large answer, right? Let's see if that works. I'm just going to copy it and paste it right here. Nope, that was not paste. Control V. No, that wasn't it. Hang on. Control C. Control V. There we go. Check answer. Correct. We got it.